lines have two key pieces of information for me to be able to differentiate exactly where a line would fall on my coordinate plane. Every line, in order to graph it, is I need to know the two pieces of information. Hey, I need to know a point that's on the line, and I need to know a direction that that line is going. For example, there's an infinite number of lines that go through that point. I can have the horizontal line that goes through that point. I can have a vertical line that goes through that point. Or I can have an infinite number of diagonal lines that go through that point. I already showed you how we figure out where points are in the coordinate system. Well, we need to figure out how we discuss the direction of a line. And we call the direction of a line in linear equations the slope of a line. And a key thing to point out here, that only linear equations or straight lines have a slope. If I were to graph a parabola, there is not a slope of a parabola. There is not a slope of a circle. We only have slopes if I have straight lines. The definition of the slope of a line is as follows. The slope of a non-vertical line, and that's a key point, is the ratio of the line's rise to its run. So if I have a non-vertical line, for example, this line right here, we define the ratio as how much it changes in the vertical direction from one point to the next. This distance right here, we're going to call its rise. And how far it changes horizontally from one point to the next, we call its run. The typical equation that you have used is, hey, the slope is equal to the rise over the run. Another way to think about the rise over the run, it is the change in y, over the change in x. So if I want to find out how much a number changes, well, I just subtract one value from the other. So I can write either the following equation, take my second point minus the first point for my y coordinates, over the second x coordinate minus the second y coordinate. Or I can write it as the first y coordinate minus the second y coordinate over the first x coordinate minus the second x coordinate. One key thing to point out is it doesn't matter which one I subtract first for the y's, but I have to subtract them in the same order when I'm doing the x's, or I won't be able to calculate the slope. When you do this equation, one thing that's neat to point out is that if you have a slope of 1, you will end up getting a line that increases at a 45-degree angle from the horizontal. We'll also find out that the slope of a horizontal line is 0, so anything between here and here has 0 is less than the slope, which is less than 1. If I have a slope of 1, and then anything between here and here, I could have a slope of 3/2, 4/2, 5, 10, 50, a million. Anything between here and here, I have slopes greater than 1. So that would be a line that's going up like this. Similarly, if I'm talking about a line that is going downhill from left to right, and it has a slope of -1, I'm going to draw it here in red. If this has a slope of -1, everything between here and here would be -1 is less than my slope, which is less than 0. Again, 0 being a horizontal line. And down here, my slope is less than -1. So if you know what the slope of a line is, you know basically how steep or how slanted the line is. And this gives you a lot of intuition when you actually just start looking at equations of lines and start to calculate things.